So how many pictures are there that could go in the first spot on the wall? How many do you have to choose from?
5.
Yep. And then for the second spot?
Oh, it's 5 times 4 times 3 times 2 times 1, and then.
Exactly. So I think that's 120, if I did my math right. 5 times 4 is 20, 20 times 3 is 60, 60 times 2 is 120, 120 times 1 is 120. And then for number 2, 6 students must walk in line for a ceremony. So if Allie and Brian must stand in the front of the line, so it has to be Allie and then Brian. And then Alex has to be at the end of the line. How many ways can the students line up for the ceremony? Well, those 3 are already set. So we only have 3 other students. So we have 3 that could go here, 2 that could go here, and 1 that could go here. So there's really only 3 times 2 times 1. There's really only 6 ways that they can line up for the ceremony, since Allie has to go first, and then Brian, and then Alex has to go at the end. Okay, Jaden, how many different groups of 3 kittens can be selected from a litter of 7?
Wait, what? You see, I'm still stuck on that question. I don't know. 3?
Okay, so let's go back to our notes. So does the order matter?
No.
No, right? It doesn't matter. We're just picking kittens. If the brown kitten gets picked first, and then the black kitten, and then the red kitten, is that any different from the red and then the brown and then the black? No, it's the same thing, right? So it would be combinations, because we use this when the order does not matter. So we have to plug it into our formula. So the total. So how many kittens total are there, Jaden?
There's 3. Wait, no.
They're picked.
7.
So, but how many total are there? 7. So we're going to do 7 factorial divided by how many they're choosing, which is
3.
3. And then how many are left?
4.
Yep. Is it coming back? Is this looking familiar?
Kind of, yeah.
Okay. So then we have to expand. So how do I expand 7 factorial?
7 times 6 times 5 times 4 times 3 times 2 times 1.
Okay, and then we divide that by 3 factorial times 4 factorial. And then we just simplify. So 4s, 3s, 2s, 1s all cancel each other out. And then 3 and 2, that equals 6, right? Are you guys okay if I cancel that out, or do you want to multiply 7 times 6 times 5 and then divide it by 6?
To be honest, whatever one is easier, that'll be.
Well, it's easier.
Yeah, I don't really think we have a preference on how to cancel something out. It's just
okay. So it won't confuse you if I cancel it out. That's what I'm asking. So 6 and then 3 times 2 is also 6. So I can just cancel those out, and then that way I have my answer without having to use a calculator. Just 7 times 5 on the top, which is 35, and a 1 on the bottom. So just 35.
Yeah, I knew that. Yeah, definitely. Mm-hmm.
I think when we originally did this, when I started doing that, it caused some confusion, but now we've gotten really good, so it doesn't confuse. Good. Okay, then Jaden, for number 4, how many different ways can a coach select a captain and team captain from a team of 12? So does the order matter in this situation?
Yes.
Yes, it does. So if order matters, then we know it is permutations Where's my permutation notes? I don't know. Did we not write them?
Difficulties.
I can't remember. So we just said though, if there's a captain, how many are there to choose from? And then how many are there to choose from for co-captain? This one's much easier. So how many options are there for captain?
12.
12. And then for co-captain?
11.
Yep. And then what's 12 times 11?
132.
Yep.
Yeah, you see, I knew that. You know? Yeah, definitely.
Okay, Jade, what is the probability of rolling an even number on a dice?
3 out of 6.
Yep, 3 out of 6. Any questions? How Jade got 3 out of 6? Or 1/2?
To be honest, if I ask a question, I feel like I'm gonna get myself confused, so I'm not gonna ask.
Well, no. So if you understand the dice, so the options on a dice are 1, 2, 3, 4, 5, 6.
It's just 2, 4, 6.
Yep. So then for even, that'd be 2, 4, and 6. So that's 1, 2, 3 out of 6. Okay, and then a bag has 8 white marbles and 7 black marbles. What is the probability of selecting a white marble?
8 out of 15.
8 out of 15. Very good. And then what about not selecting a white marble?
7 out of 15.
Very good. Selecting a white marble, putting it back, and selecting a black marble. So when it's and, do you remember what we have to do?
Take one away.
Well, this one says it puts it back. So there is replacement here. So let's just start. So first, the probability of selecting a white marble, we said was 8 out of 15. And then we're putting it back and then selecting a black marble. So remember, when it's and, that means you have to multiply. So now selecting a black marble, the probability we said is 7. And we're not going to have to take one away because they put back the white marble. So let's see. We have 56 over 15 times 15. I think that's 225, but just in case. Yes, 225. Okay, and then Jade, you're right for C. So this one says selecting a black marble and then selecting another black marble. So it doesn't tell us that they put it back. So one less is going to be there. So the probability of selecting a black marble is 7, 15. And then the probability of selecting another black marble, Jade, do you know what that's going to be?
8 out of 15.
So they already took out one black marble. There were 7. So now how many are there to choose?
Oh, 6 out of 15.
And again, one's already out. So now it doesn't say they put it back. So instead of having 15,
14.
we only have 14. That'd be 42 over 15 times 14, which is 210. All right, any questions on the probability review or the, it's also the Unit 10 application.
Oh, great.
So you don't have to do it. You could just cross this off. I'll excuse the Unit 10 application.
Yes. Thank you.
Yes.
Okay, what was that low voice though? You went, yes. And I was like, okay, wow, Jade. Well, there's a morning voice right there.
They do call me Course Junior sometimes.
Hey, we might be able to finish like everything together.
Apparently.
We could probably do the study guide and the test because we just have the problem solving task and then study guide and test. Hey, Jose, we're on page 71.
Right as Jose pops in, it's about cards.
I was
Okay,
just thinking that too right now.
so Mrs. Jakeman is teaching her class about probability. She has 10 cards numbered 1 through 10, which she mixes up and stands on a shelf turn so that the numbers do not show. She turns the cards around one at a time. The class has to guess whether the next card will have a higher number than the last one turned or a lower number. The first card turned is the 3. Okay, so everyone understands there's just the numbers 1 through 10 in each card for these 10 cards, and then only one of each. So the numbers 1 through 10. So the first card is a 3. So what we know about probability, do you think the next number would be higher than 3 or lower? What's
Higher.
most likely?
Higher.
Jade's right. Why did you say higher, Jade?
Because there's more. It's more likely to get above because there's only 4 twos in the deck.
Sorry, it kind of cut out. Can you say it one more time?
You're more likely to get a higher number because there's only 4 twos in a deck.
Oh, so these only have the numbers 1 through 10 though.
Oh, yeah.
So
there's only one less number that would be less likely to be a higher number.
yes. I think. So if we have 3, the only numbers less than 3 that are a possibility are 1 and 2, right? So there's only 2 options that are less than 3, where we could also do 4, 5, 6, 7, 8, 9, 10. There's 7 that are higher. So there's it's a lot more likely that it's going to be higher because there's 7 numbers that are higher while there's only 2 that are lower. So there are 7 numbers. Is that right? I didn't count right. 4, 5, 6, 7, 8, 9, 10. No, that is right. Okay. And only 2 that would be lower. Any questions on number 1? Okay, then the next card number is 10. What is the probability that the next card will be a higher number?
0.
0. Good, Jade. It's only 1 through 10. So 10 is the highest number. Any questions on number 2? Okay. The next card number is 4. What is the probability that the next number is higher? So we've already done 3, 10, and 4. So higher than 4 would be 5, 6, 7, 8, or 9, right? It can't be 10 because we already flipped the 10. Any questions? So it would be 5 out of 1, 2, 3, 4, 5, 6, 7. Any questions about number 3? Okay, the next card number is 7. What is the probability that the next number is lower? So what are the options that it could be that are lower than 7? Let's list them. So what numbers could be flipped that are less than 7? Could be 1. What else?
2.
2. Not 3, not 4. So then
5, 6.
5 and 6. Thanks, Jose. So it would be 4 out of 1, 2, 3, 4, 5, 6. There's 6 numbers left. Any questions on number 4? All right, the fifth card is the 1. When the sixth card is turned, the probability that the following one is higher is the same as the probability that it is lower. What must the sixth card be? So whatever one comes here, there's 2 numbers that are going to be higher that will be left and 2 numbers that are lower that are left. Does anyone know what number it is then?
You see,
What, Jaden?
I don't know.
Well, you can just guess. You can just pick a number. So, let's start with, so Jade thought 5. Let's start with 5 and see. So if we flip 5 here, what are the options that would be left that are higher? So after 5, it would be 6. It can't be 7, but it could be 8 and it could be 9. So then the lower options than 5, well, we've already done 4, we've already done 3, so it would only be 2 and 1. So there's a 3, there's way more chance that it's going to be higher than lower. So it's not quite 5, but she's close. So let's try 6. So what if we put a 6 here? So then the options for it to be higher, well, it already has 7. So higher would be 8 or 9, and then there's 10. And then lower than 6 would be, we haven't flipped a 5, 4, 3, and we haven't flipped a 2, and there's a 1. So now there would be 2 higher and 2 lower. So then that means that our sixth card must be 6. So it's really just guessing and checking. Okay, any questions on number 5?
Miss Moore,
Yeah.
possible I could take a picture of the notes before this?
Oh, there were no notes, Jose. This
Oh.
week is just kind of reviewing and then the test.
Okay.
Okay, you guys ready to do the study guide and test? And then you'll be completely done for the week.
Yeah.
Sound good? Okay, so let me open up Canvas. And you guys too. So go ahead, log into Canvas. Okay, and then scroll down to week 16 and click on the Unit 10 study guide. I'll give you guys a second to get there. All right, are you guys there? Are you ready to start or do you need more time?
Study guide, right?
Yep,
Yeah, I think I'm good.
we're good? Okay. All right, Jessa painted 4 pictures. How many different ways can she arrange them on her wall? So does the order of her pictures matter?
No.
Nah.
Nope. So then how many options does she have for the first spot on her wall?
4,
4. And then for the second?
3,
Yep. And then the third
2.
and the last?
1.
Yep. So 4 times 3 times 2 times 1 is
24.
Yep. So she's got 24 different ways she can arrange those pictures on her wall. Okay, number 2, it says, I think this is supposed to say the order matters. So if the order matters, is it a permutation or a combination?
Permutation.
Oh, you know what? No, wait, sorry. It's talking about question 1. So based on question 1, did the order matter?
No.
No.
So is it a combination or a permutation then?
C.
Yes. Yep, it didn't order, and that's why it was a combination. Very good.
I just guessed. How did I get that right?
Because you didn't really guess, Jaden. You knew it.
I did?
Clearly. Okay, the Cosmetology Club has 8 members. They will be selecting a president and vice president to represent their club. How many different ways can they fill these spots? So does the order matter?
Yes.
Yes. So if the order matters, what is it? A permutation or a combination?
Reputation.
Permutation. Yep. And then we need to figure out the president and then the vice president. So how many club members can be the president?
8.
8. And then how many for the vice president?
7.
Yep. So how many different ways can they be selected?
56.
Very good. And then we already answered number 4 because we said the order does matter. Yes. So it is a permutation. Any questions? Okay. A fun-sized bag of M&Ms has 4 red, 3 orange, 5 yellow, 3 brown, and 6 green M&Ms. Calculate the probability of randomly selecting an orange M&M.
Okay, first off, how do they have that many M&Ms in a little bag?
I bet it's pretty close to that. How many M&Ms do you think are in one of those little fun-sized bags?
I mean,
It's probably the equivalent of like a Lay's bag. You know, Lay's is like 60% air and then 20% chips, and then you know that other 10% is just gone in the Ethereum.
I guess you're probably right. So I just counted these up. So there are 21. I would say probably like in a small bag. There's probably like 15 M&Ms though, don't you think?
That's what I'm saying. Like, how did they get that much?
Yeah,
What store did they go to?
this was a very generous fun-sized bag. So how many of them would be orange?
Dang it, Paul, shut up. Anyways, 3 out of 21.
3 out of 21. Okay, and then we have the same bag. Now, what's the probability of randomly selecting a brown M&M?
3 out of 21.
3 out of 21. There's 3 browns, and there's still a total of 21. Okay, now what's the probability of not picking a yellow?
16 out of 21.
16 out of 21. Good, Rick. So there were 5 yellows, right? So then of not picking a yellow is anything other than that. So 16. Good. Okay. Now picking a red or a green M&M. Do you guys remember when we do probability with or, do we add or do we multiply?
Add.
We add. Okay. So picking a red or a green M&M. So what's the probability of picking a red?
4.
4 out of 21 plus a green M&M. So what's the probability of the green M&M?
3 out of 21. No, wait, I'm tripping. 6 out of 21.
Good. So we add those together and we get
10 out of 21.
10 out of 21. Good. All right, now the probability of picking an orange or a yellow M&M. So what's the probability of picking an orange? We said that above was 3 out of 21. And then a yellow is what?
5 out of 21.
5 out of 21. So
8 out of 21.
8 out of 21. Thank you, Jaden. All right.
Answer is 12 out of 21.
Is it 12 out of 21?
Yeah.
A red, orange, or yellow. So red, orange is 7, and yellow is 12. Very good. No, Teddy, mommy's working. No, Teddy. You need to go back out there, please. No. Sorry. Okay, a bag of marbles contains, oh, this is a different bag. So marbles contains 3 red, 4 yellow, 2 blue, and 1 green. So now what's the probability of randomly selecting a red and blue marble? So if it's an and, what do we have to do?
Add. No, wait, multiply.
We have to multiply. So think like when it's and, if it's or happening, it's going to be a lot more likely. And that's why you add them, because it has a high chance of that happening. If you're saying this and something, that's 2 things that have to happen. So that's going to be a lot harder to get to happen. And that's why we multiply, because we get a smaller probability. So yes, so a red marble, what would the probability be of picking a red?
6 out of 100.
Oh, okay, you're giving me the answer. So let's see. So a red marble would be 3 out of 7. It looks like there's 10. And then picking a blue marble, there's 2. It didn't say they put it back though. So now there would only be 9 marbles. So now we just multiply straight across and it would be 6 out of 90. Any questions on 11? All right, number 12. What's the probability of randomly selecting a blue and green marble? So selecting a blue, what's the probability of picking a blue marble?
I don't know.
2.
2 out of our total, which is 10. Yep. And then picking a green. So it's not saying that the green or that the blue one was put back. So the green marble would be 1 out of, there's only 9 though now.
Oh, so 2 out of 90.
2 out of 90. That's right.
You see, I knew that.
Okay, now of not selecting a blue and green marble. So we said the chance of selecting a blue and green was 2 out of 90. So what's the probability of not selecting a blue and green marble?
88 over 90.
Yep. Okay, and then we have our conditional probability. So 10 boys and 10 girls were asked what board game they preferred to play, Candyland or Chutes and Ladders. Their responses are recorded in the table above. What is the probability that they preferred Candyland given that they are a girl? So we're not looking at this column, at the boy column, because it says given that they are a girl. So we're only looking at the girls. So how many preferred Candyland?
80%.
Yep. There are 8 out of the total girls, which was 10, which would be 80%. Any questions? Okay. And then what is the probability that they preferred Chutes and Ladders given that they are a boy? So we're only looking at the boy column. And how many of them preferred Chutes and Ladders?
50%.
Yep, 5 out of the 10, which would be 50%. Very good.
Wait, Miss Moore? I missed number 6. Okay, yeah, I got it.
Okay, good. Any other questions?
I missed number 4.
Number 4 is a combination, not a permutation. That's what it says on the thing. So they got it wrong.
Oh, that's wrong.
The more you know.
I'll fix it. I'll give you guys the full points. That's definitely, the order definitely matters. And so it is a permutation. Okay, let's see. Let's see. Let's see. Award points for both. Yes. Okay, so that might have automatically fixed it for me.
It's just I got it wrong.
Maybe it'll take a second. I don't know. I'll go in and give you guys full credit after we're done if it doesn't. Okay, and then let's go ahead. We can do the test. We still have time. And then you guys will be totally done for the week.
Any Kahoot work today or no?
What's up?
Any Kahoot today?
I didn't make a Kahoot today. Sorry.
You lucky, Rick.
And so are we gonna talk about the podcast, or are we just gonna ignore that? Like, just absolutely defeated you on Friday.
You know what? That's what I
Thursday.
say. Next Tuesday. That's why I said Tuesday. You better be ready, because I was actually gonna win this one. I knew it.
You know, I'm like the Conor McGregor of Kahoot. I'm just constantly winning.
Did he get knocked out by a boxer?
Yeah, he got knocked out by Floyd Mayweather.
I'll make sure to do a Kahoot next week so that even though we don't really have any, we're just reviewing for the final next week. But yeah, I'll do one. All right, so the Unit 10 test. Jessa painted 3 pictures. How many different ways can she arrange them on her wall? So for her first picture, here's 1 picture, 2 picture, 3 pictures. So how many does she have to choose from for this first one?
3.
Yep, and then for this one?
2.
And then for this one?
1.
Yep, so she can arrange them 6 ways. Okay, does the order matter on number 1?
No.
Nope. So it is a combination. Okay, the chess club has 10 members. They will be selecting a president and vice president to represent their club. How many different ways can they fill these spots? So we have our president and then we have our vice president. So how many people for president?
10,
And for vice president?
9, which will be 90.
Yep, very good. Okay, does the order matter?
Yes.
And so it is a permutation. Okay, we've got another bag of M&Ms. Let's see how many we have. 7, 12, 15. We still have 21.
All right, what store are they going to?
It's all made up in my head. It's whatever I decided. So
You the owner of the store?
yes, I have a very generous M&M store.
All right, can you send me the location?
Have you guys ever been to M&M World?
No.
Oh, you guys should go. It's a pretty cool place. Anyone else? Jaden hasn't. Jade, Jose, Rick, have you guys been?
No.
Oh, so it's in Vegas. And whenever you guys go to Vegas, you should go. It's a very cool place.
All right, bet. I'm going next week.
Well, in a 7-ounce bag, there are 210.
Oh, look it up in look up a fun size bag, Rick. How many are in a fun size bag?
20 to 22.
Oh my goodness. Your teacher made up the perfect amount. 20, between 20 and 22, 21. And look, I did 21.
Wait, how come I've been getting like 10, 15 in a small bag?
No, you have like that blind eating where you think it's like 15, but it's actually like the same. It's like 20.
Oh, for real?
And you're just downing them like it's nothing.
I mean, technically, they are nothing. They're just little bitty candies.
Yes, but there's a lot of them in there. There's between 20 and 22. All right, so picking a green M&M. How many are green?
6 out of 21.
6 out of 21. Okay, what about picking a yellow?
5 out of 21.
All right, not picking a yellow.
16 out of 21.
Yep. Okay, a green or an orange.
Wait, you're going so fast.
Oh, sorry.
Dude, it's the same thing.
You're going so fast.
It's the
It's
same
the same question. Yeah, it's the same questions as what we just did 2 minutes ago.
Yeah, the numbers I just changed the numbers. So
See, we should have done cards. You know?
That's true.
or maybe I didn't even change the numbers. I might have just changed what I asked for, green or orange. Probably just these ones.
Probably.
I don't know. Okay, so then if it's green or orange, are we going to be adding or multiplying?
Adding.
Adding, good. And we add. Or not, or sorry, or we add. If it's and we multiply. Okay, so the probability of picking a green M&M would be,
oh, sorry. It would be 6.
6 out of 21, and then plus picking an orange.
3 out of 21.
9 out of 21.
Yep, so it'd be 9 out of 21. Okay, what about
8 out of 21.
an orange or a yellow? 3 orange and 5 yellow, so yep, 8 out of 21. Okay, a red, orange, or brown.
10 out of 21.
There's 3 red. Oh, wait. There were 4 red, 3 orange, and 3 brown. So yes, 10 out of 21. Okay, now we have our marbles. We have 3 red, 4 yellow, 2 blue, and 1 green. So what's the probability of selecting a yellow and blue marble?
8 out of 90.
How did you get that? You're too fast, Jaden.
Well, first it'll be 4 over 10,
Yep,
and then 2 over 9.
excellent. Which gives us 8 out of 90. Okay, picking a blue and red marble.
Do I really have to say it?
You can let someone else want to do it. Rick's gonna. You trick test?
Come on, Rick.
I was gonna make I was gonna make a comment about Jane stealing the show, but then I was like, no, I lost it.
Okay, so what would be the probability of picking a blue marble?
2 over 10.
Yep. And then a red marble?
3 out of 9.
Yep. So 6 out of 90. Okay, and then what would be the probability of not selecting a blue and red marble?
Come on, man. Come on, Rick. You at least know this, right?
So the probability was 6 out of 90 of picking blue and red. So of not would be.
Did someone call my name?
It'll be 84 out of 90.
It would be 84 out of 90. Yep. All right. We just changed up the numbers a little bit. So what is the probability that they preferred Candyland given that they are a boy?
80%.
What was that, Jade?
50%.
Yep, 50%. So given that they are a boy, we're only looking at these 10, and then the ones that picked Candyland were 5 out of the 10, so 50%. And then the probability that they preferred Chutes and Ladders, given that they are a girl.
20%.
Yep, so 20%. Only 2 out of the 10 picked. 2 out of the 10 girls, so 20%. All right, submit that and see if we got 100%.
Yeah, we got 100.
All right, no mistakes.
Miss Moore,
Yes.
what was number 13?
Number 13,
Yeah.
84 out of 90. Yep. All right, so you guys are done for the week. Next week, we just start final review.
Yeah.
And you guys are done. You could be done with math forever if you wanted to. You'll have your 2 years done. Algebra and
Wait, for real?
geometry. Yep.
And don't think about it, Jaden. Take that last, just take that one. Take that final one. I'm unfortunately having to do the.
You're gonna do the 3 years. You're gonna take algebra 2, Rick.
Yeah, so I have to do the AP one.
It says
Oh.
number 9's wrong.
Really?
Yeah, it says number 9. The correct answer